Welcome back to another stats video. Today what I want to do is look at finding a confidence interval for paired samples. In one of my previous videos I looked at independent samples, but what if we have paired samples? Another way to refer to this is dependent samples. So I'm going to try to go through this fairly quickly, and you can go back and watch it again if you missed something. But here we go. Here's my example. The table gives the average high temperatures in January and July for several European cities. Write a 90% confidence interval for the mean temperature difference between summer and winter in Europe. So these three key words. The first thing is 90% confidence interval, so I know I'm going to make a confidence interval. Mean tells me that I'm dealing with means and not proportions, so I'm going to use a t distribution eventually instead of a z distribution. X that out. And I'm looking at the difference between summer and winter. So that means I'm comparing two samples. And in this case, since we're taking the summer and winter temperatures from the same cities, that makes it a paired sample or matched pairs. Sometimes this is referred to as matched pairs because I can match these temperatures up. And there's all my temperatures. I'm not going to read through those. You can look at those if you need to. Well, the first thing I need to do is check my assumptions and conditions. The first assumption condition that I need to check is paired data. And in this case, the data are paired by city. The second condition I need to check is randomization. Well, in this case, I need to be careful because these cities might not be representative of all the European cities, so I should be cautious when I generalize the results. If these do not represent all European cities, then my results would be bogus. And the other thing is I didn't randomly choose these cities, so I hope I did not randomize, I hope that they represent the European cities. The next assumption and condition is the 10% condition. And in this case, 12 cities is definitely less than 10% of all European cities. And then finally, I need to check the nearly normal condition. And when you look at the histogram of the differences, like here I've made a histogram of all the differences. I took each one of these, 75 minus 34, 72 minus 36, 76 minus 42, and I found those differences and put those into a histogram, and that's nearly normal. So now that I've checked my assumptions and conditions, I can say since the conditions are satisfied, the sampling distribution of the differences can be modeled with a student's t-model with 12 minus 1 equals 11 degrees of freedom. We will find a paired t-interval with 90% confidence. Well, whenever you have, maybe I should have said this at the beginning, but whenever you have paired data, you are going to treat this just like a one sample t-interval. That's all you have to do. Let me show you why. I've taken all of my data for, let me go stat, enter, here we go. In list number 1, I have all of my data for the winter months. And in list number 2, I have all of my data for the corresponding summer month. I am going to go ahead, since these are paired, I am going to subtract the larger month, which is the summer, minus the colder month. So I'm going to take up here in L3, I am going to take and make this formula. L2, which is the summer month, minus L1, which is the winter month, and hit enter, and it takes all these differences. Like 75 minus 34 is 41, 72 minus 36 is 36, 76 minus 42 is 34, and so on. Well, now that I've done that, I can either take the basic statistics and plug them into this formula, and I could get the basic statistics doing this. Stat, calculate, 1var stats for list number 3, because list number 3 are the differences, and this gives me the basic statistics that I need in order to fill in this formula. Okay? Right here, 1var stats, 1var stats for list number 3, because list number 3 are the differences, and this gives me the basic statistics that I need in order to fill in this formula. Okay? Right here, 1var stats, 1var stats for list number 3, because list number 3 are the differences, and this gives me the basic statistics that I need in order to fill in this formula. Okay? Where is it at? Right here would be the sample mean or the mean of the differences. Right here is the standard deviation of the differences, and right here is the sample size. And then I could get my t-star using my t-table with 11 degrees of freedom and 90 degrees of confidence. But we have technology, so I'm going to go ahead and use my calculator to do this. I'm going to hit Stat, go over to Tests, and since this is paired data, I can find a t-interval, number 8. T-interval because it's means, and I'm using a t-distribution. And I am going to actually use, I'm going to use data, not the stats. I'm not going to use the basic statistics. I put the data into list number 3, so I'm going to use data. I'm using list number 3 because there's my differences. I'm also going to use a 90% confidence level, and then when I hit calculate, it gives me my interval. Make this a little bit larger so you guys can see. Here's my interval. Now I need to interpret that interval. Well, when I interpret that interval, scroll right here, it would look like this. We are 90% confident that the average high temperature in European cities in July is an average. Oh, well, let me start this over. We are 90% confident that the average high temperature in European cities in July is an average between 32.3 degrees and 41.3 degrees higher than in January. This should say an average right there. There we go. Okay, and that's the end. I tried to make it as quick as I could and give you some instructions. I hope this helps, and have fun in your stats class.